Bonjour à toutes et tous, merci beaucoup d'être là aujourd'hui. Je voulais savoir si déjà vous m'entendiez bien et peut-être ce que vous pouvez faire, est-ce que vous pouvez juste peut-être m'envoyer un petit message sur la boîte de connexion pour me dire si tout est OK pour vous, si tout le monde m'entend bien. Déjà, vous pouvez me dire comment vous allez. Donc, je commence, je vais sur la barre de chat. Voilà, donc n'hésitez pas à me dire comment vous allez. Ah, bah super. On m'entend bien, on me voit bien, super. Merci beaucoup. Alors, avant que Rudy commence, je vous propose peut-être de faire justement une première présentation de qu'est-ce qu'est le cluster. Et puis, on va commencer ensemble à voir un peu ce que peut nous proposer Rudy aujourd'hui. Donc, j'en ai pour 2 petites secondes. Voilà. J'en ai pour 2 secondes. Hop, voilà. Je vous propose un petit partage d'écran pour vous montrer justement un petit peu qui nous sommes au cluster. Donc le cluster, c'est vraiment une association qui est soutenue par la HEAFR et aussi par la promotion économique de Fribourg. Aujourd'hui, on représente en fait plusieurs types de membres. Donc, nous avons les membres industriels, mais nous avons aussi des membres académiques, des partenaires commerciaux de plusieurs sociétés. Et aujourd'hui, on a à peu près 105 membres. Au niveau des origines, donc le cluster existe depuis aujourd'hui, depuis 2005. On est depuis 2008 une association à but non lucratif et depuis 2022, on a une centaine de membres qui représentent différents secteurs tels que l'automobile, la construction, l'emballage, le médical et l'horlogerie. Alors, il y a vraiment différentes technologies. On est vraiment sur plusieurs types de technologies. On a l'injection, la micro-injection, l'extrusion, le polymère, les additifs manufacturing et tout ce qui est silicone. Donc vraiment, on couvre un large spectre de la technologie de la plasturgie. Nos objectifs, c'est vraiment vision et mission, c'est vraiment de se dire qu'ensemble, on est meilleur. Donc vraiment, l'idée, c'est vraiment ensemble de créer de la collaboration pour vraiment ensemble créer des projets à forte valeur ajoutée. Les valeurs de notre collaboration, évidemment, c'est toujours les mêmes. C'est la transparence, l'intégrité et la flexibilité. L'idée vraiment aujourd'hui, c'est d'offrir à nos partenaires les meilleures valeurs pour aller de l'avant dans leur projet d'innovation. Nos missions, c'est vraiment de promouvoir la technologie d'innovation et de la plasturgie, favoriser les partenariats entre public et privé. Donc, c'est vraiment de se dire que les universités peuvent travailler avec les industries. Et puis, c'est d'offrir au fur et à mesure du temps des formations continues adaptées à tous les personnels. Donc, vraiment, l'idée aussi, c'est de créer des opportunités de réseautage. Donc, tous nos événements sont toujours là pour vraiment réseauter et faire des affaires ensemble et évidemment vous offrir des projets à haute valeur ajoutée. Alors, au niveau de l'organisation, on est une association, donc on a un comité stratégique avec des PME, des professeurs et puis tout type de représentants, qui soient en Suisse romande ou en Suisse allemande. Voilà, ça vous donne un peu une idée du nombre de partenaires qui sont chez nous. Et puis voilà, tous les membres et partenaires du Swiss Plastic Cluster. Quelques activités et prestations. Donc aujourd'hui, on a des formations en collaboration avec la FSARM, avec énormément nous avons des très bonnes réductions pour les membres du cluster. On a aussi ce groupe innovation technologie avec des événements à haute valeur ajoutée qui vont arriver très bientôt. Et puis, on a aussi la coopération commerciale. Donc, par exemple, sur le stand commun avec la Swiss Plastic Expo, des voyages d'entreprise, des opportunités pour les membres de se rencontrer dans un contexte professionnel et ensemble de créer des opportunités commerciales. Et puis, on a aussi des opportunités de réseautage. Donc, vraiment avec des petits déjeuners. Là, on l'a fait récemment avec l'IRAP, mais aussi avec des assemblées générales et des événements. Juste un rappel, donc, pour nos prochains événements, on aura donc des événements le 22 septembre avec la robotisation des chaînes de production avec Muller et Stobli. Donc, je vous invite à vous inscrire sur notre site internet si cela vous intéresse. Nous avons le NTN Innovation Booster Plastique qui va zéro émission qui aura lieu le mercredi 26 octobre. Là aussi, n'hésitez pas à venir, ça va être un très bel événement qui aura lieu au Théâtre de l'Équilibre. Information à suivre très bientôt. Et puis, nous avons des formations qui est quasiment complète. Donc, malheureusement, pour cette formation, ça ne le fera pas. Mais pour le 22 novembre, je vous invite à suivre la conférence Contrefaçon et injection plastique qui sera sur toutes les solutions autour des contrefaçons et des solutions qu'on peut apporter, nous, en injection plastique, comme la nanostructuration, etc. On a évidemment notre gros event qui aura lieu, qui est le Swiss Plastic Expo. Et ça aura lieu du 17 au 19 janvier 2023. Et ça sera avec comme grand highlight le jeudi 19 janvier avec la journée de la Romandie où il y aura des speakers, des thématiques sur plein de sujets autour de la plasturgie et sur l'innovation. Voilà, je vous invite évidemment à nous suivre, donc à nous suivre sur le site internet, mais aussi sur la page LinkedIn. Donc voilà, je vais arrêter le partage et puis je vais donner la parole à mon ami Rudy. Est-ce que tu es là, Rudy? Est-ce que tu es là, Rudy? Ah, voilà. Hop là. Rudy, est-ce que tu es là? Est-ce que tu nous entends? Rudy. Voilà, est-ce que vous entendez Rudy? Bon, parfait. Vous entendez, tout le monde entend bien Rudy? Je vous laisse juste écrire un petit message. Oui, tip top. Alors, on peut y aller. Rudy, à toi de jouer. Tu es donc co-animateur, Rudy. Tu peux ouvrir ta présentation.
Future generations to meet their own needs. And if you look up what sustainability means or to sustain means as a verb, it means to keep something in operation. In other words, to perpetuate things. And this is certainly one of the challenges that that the United Nations have addressed in many different COP meetings and in many different documents. And for most of you, again, the Sustainability Development Goals, I think the 17 are probably very familiar, which is typically summarized or put together in these 5 Ps. It used to be the 3 Ps, which reflect planet, people, and prosperity. In other words, environment, social aspects, and economy. But it obviously has also to do with the fact that we need to collaborate and that we need to have a peaceful environment where we are able to collaborate. The issue is that since this document was published in 1987, there is still, after 35 years, we are still very much dependent on fossil fuels. In other words, we are taking fossil fuels in the form of crude oil and natural gas, and we just turn it back into the atmosphere, and that's becoming a challenge. It means that if we want to sustain ourselves, that we need to reflect on what the consequences are and have been of this way of operation for our society and the globe, because everything is very much dependent on these fossil fuel resources. So what I'm going to do is I'm not going to talk about the big pictures. I will make a few mentions of that, but I would like to put that in the context of plastics and what does it mean for plastics, which is one of the materials that is very much visible, very much under the gun, as I would say, although on the other hand, we are very much dependent on it too. So if you want to put this into the context of sustainability, what is the role of plastics in this to sustain ourselves as a society in the future? What does it mean is something that I would like to elaborate a little bit on. So if you look at it from a high level perspective, then there are 2 big, you can summarize it in 2 big challenges. One is obviously energy. The only source of energy that we really have is the sun. Now the sun will be around for several billions years, so we don't have to worry for the time being about that. But one of the things that we are confronted with is the transformation of this energy that the sun brings in various shapes and forms of wind and whatever. How do we transform that into something that we can use, which is called work? And this has thermodynamic limits. So we cannot transform 100% of everything that we get from the sun into something that is useful. That would be certainly very much optimal. On the other hand, we need this energy in order to create materials. And these materials are the basis of the objects that we have. And we are able to generate. Recently, somebody published that the amount of anthropogene, or in other words, man-made or human-made objects using resources from nature, we are using more, we generated more than the total amount of biomass that is at the moment available on Earth. The other problem that we have with material is not so much the material in itself, but is first of all the energy that we use for it, and second, the fact that after use, and we use it only for a limited time with few exceptions, we consider it as having no more value. And this is another important challenge, valuing aspects. To some extent, it is a socio-economic aspect, not necessarily a technical issue. As a consequence, we will have we have created ourselves in the last 250 years a lot of challenges, which typically are reflected into this list that you can see there. Climate change, the fact that we have not more drinking water available, ocean acidification, and so on. So in other words, the Earth seems to be changing in the environment, it is not a problem for the Earth, but it is a problem for the way we continue to live in the context to sustain ourselves as a human race. So one of the perspectives that you will see or often see is maybe a little bit reflected in a different way, is what's the use of it? Let's just take advantage of the situation and make the best of it for the time that we're here on this earth, because things are getting messed up anyway. Now, obviously, this is not necessarily the right approach or the right attitude if we really want to continue what we are doing in a way that we sustain ourselves as humanity, as organizations, and as individuals. So one of the most popular thing today is the so-called circular economy, and I show you here a number of ways to represent it. It is a bit of a simplistic version of what circular economy or circularity means or stands for. It's easy to understand, but the question is, does it really relate to the reality? Most of these circles, for example, don't have a stream that says waste. You know, we cannot reuse everything again. We cannot keep everything 100% and indefinitely into a loop system because of the constriction or the constraints that the energy and the laws of thermodynamics tell us. So what we are trying to do is we are trying to turn the linear system, as it is called, we take, make, and waste into something where we don't waste anymore, and we try to recover as much as possible into this. The issue with that approach is that it also implies that we will need to behave in a different way, because today in the linear system, we are basically shifting the burden from one actor in the system to the next one. So in other words, if I buy something or if I sell something that is recyclable, so to speak, and fit for, I make it essentially somebody else's problem. And this is an issue that needs to be addressed. So shifting the burden is not necessarily a solution that will help to make, even if it's only 80% that we can recover, optimal for such circular economy and to sustain ourselves. The thinking, I think I would say the thinking flaw is that we've been used to think in terms of linear systems. In other words, 1 + 1 is 2. The reality is that 1 + 1 is not really true. 2, it can be either more or it can be even less. So we are thinking in terms of mechanical systems. So like a watch, for example, it's very complicated. Yes, you need to be an expert to make this thing, but the moment you take out one of these wheels or whatever, nuts or bolts, the thing will stop working. So it's not really a good representation or a good way of thinking that the individual parts, the sum of the individual parts is equal to the total. So the reality is more something what I would call this elastic ball. You know, you have a number of elastics that all symbolically represent a kind of like a circular, an ecosystem, kind of like a closed loop system, and all together they make the Earth. And it is this interactions of all these loops that actually creates an organization, creates a system, creates the way we developed our societies. And in that sense, if we take away one of these loops, the ball will not necessarily disappear, but if we take too many of these loops, then we are going to lose the ball. And therefore, this is a real system, and therefore this is a complex system. That means every elastic band will affect the other elastic band. There is a feedback. Whatever we do, there is always a feedback. They have consequences. So I represented on my left-hand side, if I look at the screen, kind of like a more realistic representation of a so-called circular value chain for packaging. And then you see that there are many, you probably cannot read the details, but that's not necessary. The point is that you see many, many, many actors there that all interact in order to make this loop possible. And everyone plays a role. And we as an individual or as an organization or as a region or as Europe or as the world are just one of these blobs there, which I call me. So this is very complex, and therefore, if we really want to do something on sustainability, the question is, well, what is my position here in this whole big and complex world, and how can I better understand what I need to do in order to contribute that the entire system will become sustainable. So that means we need to clarify our position in the first place. And that means you need to understand first, what are the elements that determine your position. And it's not just that you may introduce, let's say, as an organization, solar panels on your big roof that you have from your storage space. That's not what the point is. The point is also, how does that affect the entire activity that I have within the total value chain. So that means we will need to also be ready to adapt to the others, to all the other ones. And this is going to be probably one of the bigger challenges that we have. Now, if we go back to plastics, then the culprit is often packaging, because this is something that we see every day, that we see every minute. And the amount of packaging has been growing directly proportional with the population growth. So, which you can see in these graphs. I put these two graphs on the same scale, and you can see that the slope is essentially the same. Still, even if packaging and plastics protect food, we still generate a lot of waste, 1.3 billion approximately per year. Compared to the global plastics, 400 million tons. I rounded the numbers here to make it a little bit simple. And from that 400 million tons, there is about 160 million tons going into plastics. And it's everywhere. So packaging, I mean. So, and plastics are everywhere. Those 400 million tons are also there where we don't expect them. As such, it's not an issue. So what is the issue? They contribute to the global greenhouse gas emissions, and that changes the climate and so on. And plastics contribute about something like 4 to 5%, which is mainly related to the production of plastics, which approximately is calculated at about 2.5 ton per ton of plastics, that CO2 or CO2 equivalents are being emitted. And this is also mainly related to the fact that we're using fossil fuels in order to make plastics. But that's just one element. The other element is that after the 70 years of plus years of using plastics, we have also polluted our environment. And this is certainly an issue. And we continue to do littering. We have a lot of buckets around, but look at the buckets. Often they are overflowing, or often there is a lot of, not in the bucket, but next to the bucket. We also have a lot of single-use products where after use, we don't see what the value is, and therefore we just discard it in the most easy way at our disposal. And the alternative is that we need the alternatives that we have, paper or whatever it may be, bioplastics and so on, also need recycling. They also need to go to the same process, and that will require, we need to be able to distinguish between all these. A study was being done and projected in terms of recyclability. Is everything as we have it today recyclable? And then you can see that actually the strategy that you need to follow is not just only either mechanical or chemical recycling, because that will only get us so far. We will also need to think about reducing or substituting what we have today based on the fossil fuel feedstock plastics that we are making. Now, the good news is that plastics should not be considered as something that is really the worst thing on this planet, because the alternative, if we are going to alternative replacements like paper, glass, metal, then our greenhouse gas emissions, given the current situation for making glass and so on, will increase fourfold. So that's not really the way to go. So we also need to be careful when we are going to our so-called classic alternatives, because plastics are really a carbon sink as long as they are in use, and they are also the lightest possible material that you can think of, which also, when you need to transport it, is an advantage. So plastics are certainly essential for many of the things that we do, and also for food preservation. You can debate about how long it needs to be preserved, and that depends a little bit on the local geography and the local uses. But certainly you are using a lot less energy than when you have to make it from all kind of other stuff, if it's überhaupt possible. So these are just to illustrate that the weight of plastic is basically you're using less material. You can do much more functional stuff than you would be able to do with the more conventional materials. The challenge is that we all know this, that we should not litter, we should not incinerate, we should not landfill, and we should actually value the material. We should value energy, we should value nature, and we should value diversity. But for some reason or another, we don't seem to be able to do this. So in other words, many of the issues related to plastics are not really a technical issue, but a socio-economic issue. Maybe to illustrate this in terms of plastics, to give you a number of ideas. So the amount of plastics that is consumed in Europe is about 130 million tons. And you can read the number. The recycling rate, if you believe it or not, is only 72%. It's not even 100%. It's in principle recyclable paper in its various shapes and forms 7 times, but the reality is it's only recycled 3 to 4 times, although it has a potential of being recycled 20 times, because that's how long you can keep the fibers of the cellulose in a shape that you can still make cardboard or paper. So the global use in packaging is even more than plastics in terms of weight. Obviously, paper weighs more than just the typical plastics. And obviously, we need trees. And at the moment, we are consuming the trees faster than they can grow. And then you end up with monocultures, and monocultures have another impact on biodiversity. And it's not an ecosystem that is long-lasting for all kind of pests and all kind of issues that you may have also with the longevity of the trees. The other thing that is being brought up is obviously bioplastics, or plastics that are made from renewable resources. At the moment, we are at about, depending on how you want to calculate this, let's say about 2 million tons. In other words, a very, very small amount that is being, but remember, even bio-based and renewable feedstock, which at the moment are mainly aimed at single-use plastics packaging. You also need to collect it, you also need to separate it, and for many, this is a very difficult issue to identify what it is, what do I need to do with it, do I have the infrastructure to do this? Some are indeed industrially compostable, quite a number of them are not, and even if they end up in the environment, they will decompose somewhat faster or much faster than the classical petroleum-based or fossil fuel-based plastic, but still will generate microplastics and so on. So we still require collection, sorting, cleaning, and reprocessing if we really want to do the recycling also here. So, I mean, this sounds all kind of a little bit challenging and gloomy, but I think the key thing here is, as I say, there is always perspective. And the perspective, in order to get perspective, I have been trying to kind of like define the future in terms of a number of stages, how to become more sustainable also with plastics. Today, we are mainly focusing on the classical fossil fuel-based plastics, which we are trying to recycle in order to continue to do what we always have been doing. I believe this is buying time. Remember, we cannot continue to recycle everything 100%, and it will require energy. It will continue to have emissions unless we make some drastic steps, particularly in the production. Some companies are trying to do this by electrification, which is certainly a step in the right direction. The question is, what will be the outcome for at the end of the after-use process with the materials that we have done and made and used. I think the next step is to go to a more renewable chemistry. This is also nothing new. I mean, before the invention of plastics in the 19th century, we were using natural renewable plastics, essentially, which are now called carbohydrates and proteins, to name just two classes. So it means we are going to do a greening of the feedstock, essentially. And for that, we can use biomass. The question immediately is then, yeah, do we use food feedstock for that? The answer is, well, we don't need to use food feedstock because, as you have seen, we generate enough waste that is much more than to make polymers that we can use than we at the moment are using. So there is abundance of non-food feedstock available to make this happen. But ultimately, if we really want to become sustainable, then we will need to apply the principles that nature has also been working on for the last so many years and continue to work on. And that's called, we need to act like nature. Essentially, how can you biomimic the workings of nature in order to sustain, first of all, the materials that we will need in order to function, and second, how can we make sure that we reduce the amount of free CO2 or CO2 equivalent in the atmosphere, because that's really the killer element for our society. It's a very slow killer. It will last, or it goes over multiple generations. Some of us may not even live long enough to see the final consequences or the ultimate consequences. So in other words, we need to adapt in a gradual way, but doing it diligently in order to sustain ourselves. But at the moment, what we are doing is, and what is the real challenge in order to do that? I already mentioned the socioeconomic aspect, and the socioeconomic aspect is particularly seen by the fact that at the moment there are quite a number of organizations and individuals and states and so on that try to do something. Some are doing basically very little, but some are trying to do something, but they tend to work in their own bubble. They have difficulties in connecting with the rest of the value chain. And particularly if you continue to have this shift the burden to the next person, if you make, for example, a beer in a paper bottle, and you forget to mention that on the inside there is a plastic bag in it that can be bio-based, but still need to be separated from the paper, then you need to ask some questions there, because how are the consumers, basically every one of us, going to do that, and do we have the opportunity or the possibilities to do this? So that's something that we certainly need to address. More collaboration and cooperation is required. I mean, I'm not going to go into detail, but this is gives you an idea. If we would value for example, in this case, the PET bottles, and I took the PET bottle example of Switzerland, where there is a voluntary action to collect them. But only 83% since 1989, this project started. At the moment, at a steady rate, are collected, and that means collected. That means 1.6 billion bottles are being produced every year or consumed every year in Switzerland. So that's a lot of bottles. Yes, they don't weigh much, but ultimately it comes down to several thousands of tons that disappear somewhere, mainly incinerated in Switzerland. Now, if we would value them at, let's say, 10 cents the bottle, then this would represent something like 160 million Swiss francs or euros or US dollars, if you like. So this is amount of money that we are just wasting from an economic perspective. So we can start to think about how can we take advantage of this value that we are not valuing anymore in order to create economic activity. And for that, we have developed a project which we call R coins, recycling coins. So it's a crypto coin where the idea is essentially, and this is on the left-hand side, the picture, where you basically, when you buy this, you basically pay a fee, but you don't pay to the retailer, you pay to yourself. But it will be on an account on an R coin account that will not be released until you bring the bottle back in the bin. And we have a pilot here in Fribourg running to valorize this. It works via an app. So in other words, instead of taxation, we are going to reward individuals for good behavior. It can be individuals, can be organizations, it can be regions, communities, and so on. There are many variations on this. So this is another approach to address this, because it also engages or gives at least the opportunity for everybody to engage in this process. And this is important. It's not somebody else's problem. It will become your problem, but you will be rewarded in terms of participating. The second bucket that I mentioned was the biomass use. And for that, we have a project we are working on called Kera, which is about how can I use, for example, the waste from chicken feathers. Chicken feathers have absolutely no nutritional value, like hair, but it is a protein. And it's a highly valuable protein that you can use to make, in this case, as you can see the pictures below, very thin fibers, which you can use for membranes, which you can use for all kind of other stuff, because as you know, it's water resistant. If you walk in the rain with your hair doesn't dissolve, your nails don't dissolve, and so on. So it's a very resistant material if you can process it in the right way, and that's what we are doing to valorize non-food biomass. So there are quite a number of opportunities there. Another element is that will help the solution, and I already mentioned these crypto coins, is to use digitalization in a more advanced way. In other words, how can I design the optimal materials, the optimal chemicals that I need, the optimal engineering processes that I need by doing this virtually, and this is where we have developed, or we are in a project where we are developing what is called a marketplace. The intention is to bring not all, but as much as software and digital tools that are available together, so that you can kind of like go to the market and pick the number of solvers and softwares and put them together with the help of experts in the field in order to address very specific challenges that you may have. One of the big issues today is in prototyping. This costs a lot of money, costs a lot of pilot plans, and so on. The question is, can we not do this virtually? It will save us a lot of energy and a lot of time and effort. Obviously, bioplastics, renewable plastics are still important. That doesn't mean that they are not bad. They play certainly a role. And for that, we need to rethink how we are, if we think in terms of packaging, can we do this in a smarter way? And this is a European program that enabled us to make a very simplified packaging system that also is very smart in terms of it is fully identifiable, it can be industrially composted, has for modified atmosphere detects the amount of leakage that you have. It will therefore define the due date or the shelf life, if you like. And it can also be modified with natural antimicrobials in order particularly to keep fresh food longer fresh. So that's another way to develop CO2 neutral packaging. Another problem, as I mentioned, in this drive for sustainability is finding the right partners. You know, it may not necessarily, well, everybody knows their competition as an organization, everybody has a certain network, but have you the right connections? So how do you find those connections? And this interregional program was actually developed because most of the organizations and individuals are now represented on the internet, so we can find them. And this is a piece of software that enables you to find and connect with other organizations. It's not a kind of like a LinkedIn thing. It's more about this is what I do as an organization. I need products and I sell products. Where can I find those projects and who has them for me? And this in terms of a bio-based economy. A more recent program, which is more going into the biomimetics, relates to how can I use plastics or biomass, renewable feedstock, in this again, keratin from chicken feathers, but there are also a number of other materials that we are looking at from nature. How can I use these in order to develop, for example, antimicrobials in non-wovens applications? So in other words, I will have, let's call it wipes, that have a certain protective character and are fully environmentally friendly and are only targeting very specific pathogens. So in other words, we need to get together, we need to develop an open strategy, we need to open ourselves if we want to sustain our organization or sustain ourselves as a society. And that means we will need to adapt ourselves. So we need to reflect on how easily we can adapt. And in order to do that, we need to generate energy. We need to engage, you know, we need to put energy into the system in order to overcome this hurdle. And that's something that is at the moment the big challenge. How much can we invest as individuals and how much can we invest financially in order to do that? Because if we don't do that, the boundary conditions will change and are changing, not so much in terms of climate, but also the response of our consumers or customers, the response of the environment within which are essentially the boundary conditions, which will force ourselves. And if you're not prepared that this is going to come, and if you're not able to adapt to do this, then you will not be able to sustain yourself. To give you an idea of the changing environment, particularly with plastic, I mean, it can be summarized as one thing. Yes, we have the objective to, in the EU, to become CO2 neutral, the so-called Green Deal, which has an important impact on plastics, particularly on recycling and how we want to use it, and single-use plastics and so on. But it can be summarized at the moment as the changing boundaries conditions are defined in terms of taxations. There are many taxing schemes that are now becoming in place or are going to be in place. Obviously, the emission trading system is from CO2 emissions is one of them, but there are quite a number of other ones that are in place at the moment in order to so-called reduce plastics, or if we are smart, to change the way we are generating or making plastics and how we are going to use it. So there is also a taxonomy in place for the European Commission, which has a number of these 6 environmental objectives, which is a regulation. That means it is a law, or it will become law, where every company and every organization will be defined where it is going to stand with regard to these 6 environmental objectives. So the question obviously always remains, what are the practical measures? Actually, we are very creative, and I've shown you, I hope I've shown you a few approaches that you can follow in order to change the way we do things in the future. But there are many more things. So one of the things that I already mentioned is engage everybody. Try to take everybody, that everybody does something, even on their own, with their own means and their own level. Also rethink what kind of, how we eco-design, how we shape and use certain products, materials. How do we distribute these materials and products? How can we take them back? Are there easier schemes? Logistics is one of the biggest issues and the biggest contributors to greenhouse gas emissions, by the way. So how can we do this much better? Can we use digitalization? I gave you a few examples. Can we use biotechnology to solve or to address some of these challenges in the future? How do we need to work together? In other words, can we build ecosystems? You know, we don't need to work all over the globe. We can work more local. For example, that doesn't mean that we need to forget about the world, of course. And obviously, there is the element of new business models. You don't need to sell light bubbles or light bulbs anymore like Philips. Instead, you sell light. You work on the emotional aspects, if you like, but essentially, it's another way of one organization takes charge of everything to maximize and optimize the reduction of the environmental footprint. So sustainable development is not, let's say, a finish line, so to speak. It is a dynamic process. It's not even a steady state. It is a process. It is something, it's a path, it's a strategy, but an open strategy that we need to follow. What we see today, unfortunately, I find, is we see too many easy, quick fixes and hope for the best. This is a sure way to disaster in many ways. And the reality is we don't really have too much time because all these things have feedback loops and they are working what one calls exponentially. So we need to follow, in order to sustain ourselves, the more complex but the right way. So in conclusion, I can say that to sustain oneself is a process where you need to continuously adapt, and it can be an individual, can be an organization, can be a society. It also means that plastics should and must remain part of the future because they are the lowest possible material in terms of environmental footprint that you can come up with. Even nature works with polymers. They are not called polyethylene, they are called proteins, like keratin, for example, or carbohydrates, like cellulose, for example. And they sink, they take away the CO2 out of the environment in order to make the environment livable for many of the species. It's also important to invest in human energy, in other words, to encourage people to participate and to do the right thing. And everybody can participate because everybody wants to sustain themselves and their future offsprings, I believe. So that's what I wanted to say about sustainability. I hope it gave you a bit of a different twist to a challenging topic. It's not something that is a hopeless challenge. It's something that we can all together work on. It's something we need to work on. But it's also important that we go and stand in the mirror and look at ourselves and say, who is the fairest of them all? Are we really doing a good job here? So thank you very much for your attention. I hope you enjoyed this 40 minutes actually. And if there are any questions or anything that comes to mind now or later, you can always connect or contact me for further questions. Thank you very much. Raphael, the floor is yours again.
Thank you, Rudy. Thanks a lot for this very interesting news, and what you say was very interesting. I have some question in the bar chart, so maybe I can read the question. I have a question of Pedro Antonio, who said, how is the CO2 emission coming from the reusable packaging like glass and metal calculated and compared to single-use plastic or plastic with low recyclability?
Yeah, so the issue with glass is basically it's silica, so you need to first of all heat it up to high temperatures, more than 1,000 degrees, in order to make it into the glass that we know and all the very special glasses that are now on the market. These ovens continuously operate, and most of these ovens continuously use natural gas or gas, and therefore produce a lot of CO2. So that's one element. The other element, which should not be underestimated, is glass is significantly heavier. It's something like 3-4 times heavier than the same, let's say, container of plastic. That means transportation will generate also a lot of energy. So if you look at the full circle of the life cycle of, let's say, plastic bottle versus, and assuming that you recycle the plastic bottle 100% and assuming that you recycle the glass bottle 100%, you will be more advantageous with the plastic bottle, essentially, in the ideal condition.
Thanks. And we have another question of Puro Nicola. What blockchain is used for your coin?
Oh, interesting question. But at the moment, I cannot answer that question. But indeed, we are using blockchain. Actually, you can use or you cannot use. You do not necessarily need to use the blockchain technology, but you can use blockchain technology. This is a long story, actually, so I will refrain from not answering that, or refrain from answering that. But yes, we use blockchain, and then we will ask the question, what about the energy? Well, the energy is certainly manageable. It depends on how you want to operate that system.
We have a question of Line Tong. There is a pledge in Europe of 10 million tons of plastic recycled in 2025. How do you see this, and how to achieve if possible?
Well, I think at the moment we are not yet there, but that was indeed the European target, is 10 million tons. We are certainly not there. We do collect quite a lot of that, but we don't really recycle everything. And there are many challenges. One is the multi-material issue, which we need to solve. There is no coherent strategy across Europe. Every country does its own thing. There is now an extended producer responsibility that is a kind of like a directive that needs to be implemented in the 27 European countries. So that may help to advance this. But in addition, we will need to build more recycling plants if we really want to achieve this in various strategically placed locations. So still a lot of work and a lot of investments to be done. For example, in Switzerland, which was always against recycling, they incinerated and claim energy recovery. Okay, that's fine. You know, it used to be a good strategy at one time, but not anymore. But also here in Switzerland, they are going for a centralized collection system of all the cantons in order to maximize their recycling capability. And it's not only PET. Switzerland is about 800,000 tons of plastics per year consumption.
We have the last question of Chelsea Tucker. Do you think that the shift to circularity will be technology agnostic or technology use where they work best, or do you think there are some key technologies that are critical? Gasification, pyrolysis, gas phase, or mechanical chemical recycling?
Well, the answer to that is there is no one size fits all, because it will depend on what kind of plastics you will have to deal with. And this is what you see today. Also, recyclers tend to start focusing on single streams. So like, I'm only dealing with PET, not only PET bottles, but also PET trays, maybe even textiles. Or I'm only focusing on polyolefins, and then only one class of polyolefins, like high-density polyethylene. There are people that only collect garden furniture that made out of polypropylene, for example. So then with regard to the technology of chemistry, of chemical recycling or gasification or pyrolysis, I think the verdict is not out there what is the preferred or the best technology, because as you know, the idea is to get a pyrolysis oil that you will stick back into a cracker in order to get back the feedstock molecules. There is a lot of issues with regard to non-polyethylene, for example, or non-polyolefin components in there, thinking about additives and so on, what happens to all of that. And all these questions are not always very answered very well. But in short, not one size fits all. We need to work on these different technologies and certainly evaluate them as fast as possible. But I believe that it will be a very selective game in terms of better sorting, better designing of the materials, or single materials, for example, or even multi-materials, but easy to separable. And then you can go to the chemical recycling.
Rudy, it's almost the end, so I really would like to thank you for this moment. It was crazy and very, very interesting, and a new vision for the future. A big thanks. I would like, I send you in the bar chat my email if you want to receive the replay and some news from the peak and the cluster. So please send me an email and I will send you everything on mail with the Swiss transfer. So yes, really, really thank you, Rudy, for this beautiful perspective and for the future and the challenge. So yes, thank you everybody, and don't hesitate to send me a mail.
Yeah, you're welcome. Thank you very much for being there.
Thank you.
Take care. Bye-bye.
Thank you.